We'll come back now to discuss question 2, which asks us to load the OJ dataset from ISLR package. Okay, so apparently it's just a matter of loading the library, okay, into R, and then we're asked to create a training set containing a random sample of 800 observations and a test set containing of the remaining observations. Okay, so to make things reproducible for ourselves, okay, we set the seed and then sample from 1 until the number of rows. Okay, I think now you haven't forgotten the use of dimension, right? Okay, so you can actually check the dimension of OJ is so it's actually a 1070 matrix multiplied with 18. Okay, we want the number of rows. Okay, so we set the training take 100. Okay, you have to be a bit careful. So far I always put 1 to the number of rows. Okay, apparently this is so common. Sample has a form which just takes in the number, okay, and it will perform the sampling, okay, from 1 until 1070. Okay, so next is to construct the tests and training data sets. Okay, I think it's quite obvious, right? Okay, this is the training part, and then this is the minus sign. Okay, we mentioned since practical 1, it means removing the training index, so the remainder is going to be the tests. Okay, so what do we do next? So this is the first part. Okay, basically that's the answer, as you can see here. So next, we are asked to feed a tree to the training data. Okay, with purchase as the response. So what do? We have a look at what are the types inside the training, right? Okay, I need to check the class, right? So where is our purchase? Okay, purchase is already a factor. Okay, so yeah, the data is already clean and set to the appropriate type. Okay, so the other variables except buy and predictors, do I have buy? Do I have buy? Special loyal sales, bit strange. Okay, something funny here. Okay, doesn't matter. We'll just use everything. Okay, then we are asked to produce a summary of the tree and describe the results obtained. Okay, obviously a summary means this, right? Okay, so how many terminal nodes does the tree have? Okay, so in that case, I didn't realize part B is actually quite easy. We just load the tree library. okay, and construct the tree for the OJ train data set. So I think the original one probably has a by. This one is obviously removed in the ISLR library. Okay, so that's why we don't have to care about it. Lastly, we perform a summary. So it tells us that variables which are important are only 4 of them. Okay, and we only have 7 number of terminal nodes. Okay, the statistics seems to tell us that okay, for the training data itself, the misclassification rate is just 16%. Okay, not too bad. Okay, so let's clear this thing and continue. So next we are asked to create a plot of the tree and interpret the result. So based on the earlier practical question 1, okay, you probably know that it's just taking the tree and then plot it. How come we still need a text? Let's plot it. Okay, I'll move the plot over to this side. Okay, as you can see, if you don't put in the text, it's just a tree, okay, with nothing. So we need to put in the text. Okay, then label will be there, so that like what we see in the where is the summary? Okay, let's show the summary again. Okay, it tells us variables which are actually used in the tree construction, right? Okay, so loyal ch is obviously an important variable. Okay, it's the most important. Okay, and in fact, you can see the root, internal root, okay, are all the decision making is based on royal ch. Okay, and so if it's all yes, this thing is less. If loyal ch is less than this value, then it would basically straight away be able to tell us the output is mm. If it's large, it's larger than 0.7646, right? Okay, it will straight away go down to this. Okay, ch. So intermediate values, okay, they are all they are decided by the rest of the variables. Okay, so as you can see from here. Okay, so that's all we have about question 2C, right? Not something very complicated. Okay, now let's just try to answer D. We are asked to predict the response of the test data and produce a confusion matrix. Wow, this is related to predict, right? Okay, so let us go to the answer for D. It must relate to prediction. Okay, as we can see here, isn't it? So for confusion matrix, okay, we need to first perform prediction. Okay, the summary is already shown here, so no need to do it again. Okay, so perform the prediction, and we just want to know the predicted class. Okay, and then we construct the confusion matrix. Okay, by comparing the predicted result, okay, from here, okay, and compare it to the actual result. Okay, and let's see how's the matrix. Confusion matrix seems to tell us, okay, well, the accuracy seems to be quite high. Okay, to know exact value, okay, we use the formula we are familiar with from earlier practical classes. Okay, so it tells us that, oh, it's more than 80% accurate. Okay, so yeah, that is part D, right? The solution to part D. Okay, now let us look at part E. Okay, produce a prune tree with just 5 terminal nodes. Okay, based on the question 1 practical, you already know that. Okay, yeah, the 5 is here, right? Okay, just choose 5 best nodes. Okay, and compare the results with between the prune and unpruned tree, and see which is better. Okay, basically is to compare the confusion matrix and the accuracy. This one is the unpruned tree. Okay, now we want to construct a prune tree. Okay, so just construct the prune tree here. Then I can show the summary if I want to, but is it necessary? Okay, you can have a look if you want. Okay, so why do we want to show it is to roughly know how many variables are actually used in the end. You can see compared to the unpruned, here we are using much less variable, and the number of terminal nodes is 5, and misclassification rate increase a bit. Okay, compared to the unpruned one, but doesn't matter. Okay, it's not very serious. So now we want to construct the prediction. Okay, based on the prune tree. Okay, and test data, perform prediction, and finally we construct the confusion matrix. Okay, so is it very bad? Here is 30 plus 15. Okay, 49 plus 12 seems to be the accuracy lower a bit, but okay, just slightly below 80%, not very serious. So we can say that, okay, the prune and unpruned tree have similar accuracy. Okay, so which is better? Apparently the original unpruned tree seems to be better. Okay, but not seriously better. Okay, so after a small break, we'll continue with solving question 3.